trees compete for sunlight. Sunlight is one of the most important variables that a tree experiences, and is what, when we're managing a forest or we're thinning a forest or you're managing your garden, what you're really managing is which trees get sunlight. So a common question or a common struggle that maple producers have is trying to decide, is my sugar bush, does it have too many trees? Are those trees under too much competition for sunlight? There are several ways that a maple producer can go about assessing whether or not their sugar bush has too much competition. One way to do that is to estimate what's called the basal area per acre. So the basal area of an individual tree is measured as the cross section, the area, if you were to cut the stem off, of that tree at 4.5 feet. So you could go out and you could measure the diameter of all the trees on an acre, convert that diameter measurement to basal area, and then you would have the basal area per acre. To me, that sounds like an awful lot of work. So foresters 100 years ago came up with a tool that's called an angle gauge, a basal area angle gauge. And that angle gauge is simply a window or some kind of a gap, or it could be a solid piece of material. It's held a fixed distance from the eye. You stand on a specific point and you look at trees all around you. If those trees completely fill the window or more than fill the window, then that tree counts towards the basal area. The angle gauge has what's called a basal area factor. In this case, for this angle gauge, it's 10. So every tree that completely fills the window represents 10 square feet of basal area. So as I stand here and I spin in a circle and look at trees, if I count 7 trees, the basal area per acre at this point is 70 square feet per acre. If I count 11 trees, it's 110 square feet per acre. The Maple Producer's Manual, the Sugar Bush Management chapter, has a chart that allows you to evaluate whether or not the basal area that you measure in your sugar bush represents too much basal area or too high of a level of competition. So the way this works, again, is I stand at one spot. I like to start always looking north, and then I'll pick a tree and I'll say that tree more than fills the window. So there I get 1, and it doesn't matter how far the tree is away from you, but what matters is whether or not it completely fills the window. The angle gauge, so there's 2, here's 3. There's a large tree that's further away, but that fills the window as 4, 5, 6, 7, 8, 9, 10, 11. So at this point, I counted 11 trees. So that means at this point, I have an estimate of 110 square feet of basal area per acre. I would put in one of these sample points, about 1 per acre. So in this 12-acre sugar bush, I'd put in 12 points. I would take an average, and that would give me the average square feet, average basal areas in square feet per acre. What this tree is doing, or I'm sorry, what this angle gauge is doing, is really just calibrating how far you are from a tree of a particular size. So what that, the benefit of knowing that is if there's a tree that's hidden behind another tree, you can step to one side or the other. As long as you stay the same distance from the tree that's hidden, you can look at it with your angle gauge and then make a decision about whether to count it as an in tree or not, and then go back to your original starting point. So the basal area angle gauge is useful if you have a basal area angle gauge. If you don't, you can approximate what you're trying to do. The penny is a pretty good approximation. The width of the penny is about the width of the opening. And remember, you need to hold that penny or the angle gauge 25 inches from your eye. A penny is a little bit small, so it's not going to give you an exact calculation to use for the Basel area factor of 10, but it's close enough. Maybe you have a nickel. A nickel is a little bit too big, and a quarter is also considerably too big. So your best bet is to use a penny if you don't have an angle gauge, and that's close enough.